Have you ever just stopped and wondered how an AI like ChatGPT actually decides what to write next? I mean, it can feel like pure magic when it spits out a poem or a block of code from just a few words. But here's the thing. It's not magic at all. It's a fascinating process of making choices, a science really. And today, we're going to pull back the curtain on that process. It's called sampling. So let's kick things off with something I'm sure you've all run into. You're chatting with an AI, things are going great, and then all of a sudden it just gets stuck. It falls into this weird repetitive loop saying the same thing over and over and over. It's a super common problem, but what is actually going on under the hood when that happens?
Well, this is what happens because of something called greedy generation. See, by default, an AI is basically programmed to pick the single most probable, most obvious next word every single time. The result? It's safe, sure, but it's also just mind-numbingly boring and repetitive, like you see on the left. To get that richer, more creative text on the right, we have to use a totally different approach. Right, so to break free from that greedy, robotic behavior, we have to inject a little bit of, well, chaos. The solution is called sampling, and it's all about adding controlled randomness into the mix to get much more interesting, much more human-like results. At its core, sampling is what turns a predictable machine into a creative partner. Instead of always just picking the number one most likely word, the AI is allowed to look at the second, or the third, or maybe even the 20th most likely option. And that one simple change is the entire foundation of AI creativity. So how do we actually control all this randomness? Well, engineers have a whole toolkit of different sampling methods. You can think of each one as a different knob or a filter that lets us fine-tune the AI's output, its personality really. Let's open up the toolbox and look at the most important ones.
The first tools in our kit are the big ones, the main controls for randomness. These are what decide if the AI is going to play it safe and be conservative, or if it's going to get a little wild and creative.
The most common control is called temperature, and you can literally think of it as a risk knob. If you set a low temperature, the AI sticks to the most obvious, high-probability words. But if you turn that temperature up, suddenly the AI starts considering less common words, making it much more willing to take creative risks. It's really the difference between a dry textbook and a wild fantasy novel.
But of course, the second you crank up the creativity, you run the risk of the AI just spitting out nonsense, or, ironically, falling into brand new kinds of repetitive loops. And that's exactly why we need another set of tools. One's designed specifically to act as the repetition police. A really sophisticated tool for this is called DRY, which stands for Don't Repeat Yourself, and it is way smarter than just penalizing single words. It actually looks for repeating phrases, or n-grams technically, so if the AI writes, "the cat sat on the" for a second time, DRY jumps in and actively discourages it from picking the word mat, effectively breaking that loop before it even starts. Okay. Our last category of tools acts like a quality filter, because even when we're encouraging the AI to be creative, we don't want it choosing words that make absolutely no sense. These methods make sure the AI is always picking from a pool of good, high-quality candidates. Top K is the most straightforward filter. You just pick a number, let's say 40, and the AI is only allowed to choose from the top 40 most probable next words. It's like giving it a multiple-choice test where you've already removed all the really bad answers. It's safe, for sure, but it can be a little rigid.
Now, top P, also called nucleus sampling, is way more dynamic. Instead of a fixed number of options, it creates a pool of choices based on how confident the AI is. So if the AI is really sure the next word should be cat or dog, the pool of options will be tiny. But if it's uncertain and thinks, this could go a few different ways, the pool gets bigger, giving it more possibilities to choose from. It adapts on the fly. All right, now for a really crucial insight that's often overlooked. It is not just which of these tools you use, the order in which you apply them can completely, fundamentally change the final output. This is a pro-level concept. See, most systems use a multi-step process called a sampling pipeline. First, the AI generates raw scores. They're called logits for every single possible next word. Then, step by step, each of the samplers we just talked about modifies that list of scores until, at the very end, one final word is chosen. So, let's see why this order matters so much. Imagine we apply a high temperature before we do any filtering. The temperature will boost the scores of some of the long-shot words. So a word that was maybe ranked, say, number 50, might now sneak its way into the top 40.
Then, when the top K filter is applied, that wildcard option is now in the running, which leads to much more diverse and unexpected results.
But now, watch what happens if we just flip it. Here, we filter first, locking in our top 40 safest choices. Then we apply high temperature. Well, now the temperature can only reshuffle the probabilities within that already safe group. That wildcard option from before, it was eliminated from the very start. The output becomes way more controlled and coherent, even though we use the exact same settings. The order is everything.
Now, I've been saying the AI chooses the next word this whole time, but that's actually a bit of a useful simplification. To really get what's going on, we need to look at the true building blocks of AI language.
So what are these fundamental units? If it's not whole words, what is the AI actually calculating all those probabilities for at every single step? Is it letters, sentences, something else?
The answer is tokens. You can think of them as word pieces. Instead of having a massive, rigid vocabulary of every word in existence, AIs use a smaller, more flexible set of common subwords. And this is absolutely brilliant, because it allows the model to construct words it's never even seen before, like gronfalficious, just by combining tokens it already knows. It gives the AI so much more nuance and control at each step of generation.
So when you're interacting with an AI and it feels creative, or maybe it feels cautious or really formal, that's not some abstract personality. It is the direct result of this sampling pipeline we've been talking about, a series of carefully ordered mathematical operations, from penalties to filters, all working together on a vocabulary of tokens to produce that final text. It's all engineering.
Understanding these tools really does change how you see AI. You're no longer just a user typing in prompts, you're more like a conductor with the ability to tune this whole orchestra of samplers to create exactly the kind of output you want. So the real question is, what kind of performance would you conduct?